Hello and welcome. In this part, I'm going to give you a more detailed introduction to polynomial regression. In the last part, I showed you how to do a linear regression in Python, and that was the last of two parts where I went into more depth about linear regression. So now moving on to polynomial regression. So similar to linear regression, what we'll do is I will have two parts to this one where I explain it in a bit more detail, and then the next part where I'll do a polynomial regression in Python and show you how to do it step by step. And then finally, we're going to end with the next two parts on logistic regression. Hopefully this looks a bit familiar to you. It is the slide I went through in the very first part when I give a high-level introduction to regression in general. And remember that polynomial regression assumes that there's a curved line of best fit. And it's mainly associated with the equation y equals a plus b1x plus b2x squared plus b3x cubed and so on, where a is the y-intercept and b is the slope. And remember, with this curved line, the slope is continually changing, which makes it a bit harder. So, when you're doing a polynomial regression, one thing you have to be aware of is that you'll have an equation of a line like y equals 4x cubed plus 2x squared plus x, just using the example below. And one of the first things you'll need to figure out is something called the degree, which is a measure of how much that the data curves. And for example, degree of 1 is the same as a linear regression. It's just a straight line. And a degree of 2 is like a simple curve, and you can solve by using sort of quadratic way. And then a degree of 3 is sort of a more of like an S shape. It's like two curves in it. And so one thing you'll need to choose when doing a polynomial regression is how many degrees you want to input into your polynomial regression calculation. And one thing to consider is that if you pick a too high a number of degrees, it will result in something called overfitting. And if you pick too low a degree, you'll result in something called underfitting. And I've got a great example of images which I've found on the internet which show this really well in the next slide. So before we move on to the next slide, let me show you and tell you how to calculate the degree, the best way to do it. And it's very simply, it's the highest power of x, or combination of x and y, in your formula. So going back to the example of y equals 4x cubed plus 2x squared plus x, the degree would be 3. If it was 4x cubed y squared plus 2x squared plus x, it would be degree of 5, because the x cubed, the 3, plus the y squared, the 2 of the y squared, is 5. Another example is y equals 5x to the power of 8 plus 3x squared plus 6x. And in this case, the degree would be 8. So it's just the highest number of x in this case, or the sum of the powers together. If you've got x and y, if you've got multiple sort of powers going on. So let's move on to the next slide, and it's a very great image of showing, I'm telling you to pick a correct degree. And I found this on a blog by someone called Animesh Agarwal, and he provides a really great article. The link is here in the slide on polynomial regression. So I definitely recommend looking at that blog post. And what you can see here are three images, and you have the left one, which shows someone's chosen a degree of 1 with the data, the middle one where someone's chosen a degree of 3, and the right one where someone's chosen a really high degree of 20. And you can see with the left one, there's lots of bias, because what you're doing is you're just doing a straight line through the data when actually it curves. And so you're basically, when you're using that as to train your model to then predict future values, your future values will have a high bias because you're basically assuming too much. The correct one to pick is the middle one, degree of 3, because you can sort of see in the data that there's like a sort of S shape beginning to happen. There's sort of two curves going on. And on the right one, it's overfitting. You're choosing too high a degree. It's literally going pretty much in some cases from point to point, which is not what you want. You want to have a sort of as smooth as possible line of best fit without going to like a straight line. So if you need to know about degrees in more detail, definitely check out the blog by Animesh Agarwal, and the link is in the slide. So moving on, once you've found the degree to use, the easiest and best way to basically calculate, and if you want to do it by hand, the best way is to do a sort of trial and error method, and you basically have to try and find the x value when y is 0. So in your calculation of y equals 4x cubed plus 2x squared plus x, you try what the value of y is when x is 1 or when x is minus 1, and then you just try and get to a point where y is 0, and then you can solve by either using a sort of quadratic equation or by using another method. So what I'm saying in short is that it is so much easier to do it in Python than it is to do it by hand. And hopefully you sort of get that idea when I'm talking you through this in this slide, in this sort of tutorial. In the next tutorial, I will show you how to use polynomial regression in sklearn module in Python, and it is so much easier and quicker than doing it by hand, and it's probably even quicker to download a Python shell, write the code for polynomial regression, and then have it ready to do other polynomial regressions in the future than it is to do it once by hand, because it is so much easier to do in Python. So it's a quick one here, a quick tutorial. Hopefully I've gone into a bit more depth that you sort of understand more about what polynomial regression is, and I'll see you again in the next part of polynomial regression, where I'll show you how to do it in Python. And I've already got it set up. It's ready to go, and it should be on your screens and ready to be shown to the public in the next week or two. Thank you very much for watching.